Hello everyone, let's solve Leetcode problem number 39, combination sum. So what the question says, given an array of distinct integers, candidates and the target integer target. So return a list of unique combinations. So we have to return the list of unique combinations of candidates where the chosen numbers sum to target. You may return the combinations in any order. So we can return the combination in any order, but we have to return the list of unique combinations of candidates where the chosen number sum to target. So here candidates are given, the sum must lead to the target, right? The unique combination, the sum must lead to the target. So the same number may be chosen from candidates an unlimited number of times. So this is one thing important. So here we can choose the same number as well. In simple terms, we can repeat the numbers, but the numbers has to be present in the array first. So here 2, 3, 6, 7 is there. This has to meet 7, right? The addition of, the sum of a particular number should meet the 7. Here individual 7 will be equal to 7. One thing we can see, and we can see this. And another, they have another combination they have given here as 2, 2 and 3. Nothing but here 2, they have repeated 2. They have strictly given in the question as well. The same number may be chosen from the candidates an unlimited number of times. What we are doing here is, they are not, we are not caring that we shouldn't repeat the numbers. The numbers can get repeated, but it should lead to the sum 7. We can repeat the number unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen number is different. This is fine. So let's come to the example 1. So here they have given candidates 2, 3, 6, 7 and the target. So the output they have mentioned is 2, 2, 3 and 7. We saw this one, right? 3 plus 2, 5. 5 plus 2 is nothing but 7. So this is equal to 7. And also the individual 7. 7 is equal to 7, right? Explanation they have given 2 and 3 are candidates. 2 plus same thing. They have explained, right? So let's write the code and let's try to take the example. I'll just explain with the example, this example, by taking the example after writing the code, right? I'll just come here. Initially, what I'll do is, let's create the array to store the valid combinations, right? So I'll just, we'll create the empty array to store the valid combinations. I'll just give result and let me type result itself. So after this, let's make use of the helper function for the recursion. So we'll be making use of backtracking here. So mainly what is backtracking? I'll just explain in simple sentence. Backtracking is a problem solving technique. So that involves recursively, again I'm telling, that involves recursively exploring all the potential solutions. Backtracking is a problem solving technique that involves recursively exploring all the potential solutions, and we will abandon the path that will fail to meet the criteria. So if we are failing to meet the criteria, we will abandon those paths. First, we will recursively explore all the potential solutions, and we will abandon all the paths that fail to meet the criteria, so that we can go to the previous steps again to try the different options. That is one advantage of the backtracking, right? So let's continue. Next, let's make use of the helper function for the recursion, right? Let me write function I and just take target and array as parameters. So here is I equals length of the candidates, then candidates length of the candidates, right? So then what we'll do, we'll check whether the target is equal to 0. If the target is equal to 0, then we will add valid combination to the result. So how can we write that? If target equals 0, then result dot push of array, right? This is fine. Next, we will end the recursion. End the recursion will return nothing, right? We'll just return. Next, what we'll do, if the target, this one, this you will see, you'll understand this one while we are considering the example, and we will do basically this example. So I'll just write this one logic now. I'll just make use of the if condition. If target minus candidates I, iterated value of the candidates, if it is greater than or equal to 0, then what we will do, we will include the current candidate and recurse. Func, this one here, I should have given recurse, but this is fine. Func, I'll just give I target minus candidates of I. These are the parameters, right? If you see target array and this one, target minus candidates. So I have given. Let's just make use of the spread operator. We'll spread the arrays and candidates of I, right? So what we are doing here, we are just including the current candidates and we'll go on recursing. Next, we will exclude the current candidates and recurse as well. Just make use of the function again. Recursive function, I'm just making use of the function name, right? So this one, if you can observe the same thing, right here. What are all the things we have? One is parameter I. We are taking I plus 1. Next, this one. Next element in the array. Then target. Then we are having array in the parameter. Nothing but we will make use of the spread operator. All the elements in the array. So next, after this, we will start the recursion with the initial values that we are writing outside the function. Basically, we are starting from 0, right? Start the 0th index. We will start the recursion with the initial values. For that one, simple function 0 target empty array. Initially, finally, we will return all the valid combinations. Return. We have to return all the possible combinations, nothing but result within this array. Nothing but we are returning this one. So I'll just format this one. Let me hit the submit. So this works completely fine. Right. So I'll just come to description here. Let's consider this example, example number 1, and let's try to understand what we have written here, right? So starting here, we can see we will start with the empty, this one, empty combination, nothing but empty array, and the target value is 7 initially. They have given in this example we are taking, right? Target value is 7. We are starting with the empty combination as we have written here. So basically, right? Next, we have to include 2, this one. We are including this one, 2, first number. Now we have the new combination 2, and new target will be this one, a target minus candidate I. Will check whether it is greater than or equal to 0. 7 minus 2, target is 7 minus 2, it is greater than or equal to 0. It is greater, right? Then it will be 5. So new target will be what we have got is 5 here, right? Then step 2, what we are doing, we are including another 2 now. So let's include another 2 now. So the new combination will be 2, 2, right? So the new combination will be 2, 2, and the target will be 5. The previous target was 5. This one was previous target, and this one was new combination. I'll just give C. Here the new combination is 2, 2, and the new target is nothing but 5 minus 2 is nothing but 3. 5 target minus the next element we have included is 2, nothing but 3. This is going to be target. Now, this is fine. Step 3, what we are doing, we are including another 2 now. So, we are including another 2. Now, it will be 2, 2, 2, right? So, the new target will be, the previous target was 3. The new target minus this one, 3 minus 2, it will be 1. So, this will be C and this will be target, right? So next step what we'll do, we'll try to include another 2, nothing but this will be 1 minus 2 greater than or equal to 0. So sorry, 1 minus, just give me a second. 1 minus 2 less than 0. This will exceed the target, right? We will skip including the another 2. So we'll stop till here for now, right? So in the step 5, what we will do, we will include 3, the next letter. I mean, next one in the array, right? This 3. So the new combination will be now 2, 2, and 3, right? Now the new target will be 1 minus 3. So 1 minus 3 will be less than 0 or not. So it exceeds the target. So the combination 2 to 3 is valid. Why combination 2 to 3 is valid? Because when we sum this up, 3 plus 2 nothing but 5. 5 plus 2 is nothing but 7. So we will check 7 whether this is equal to 7 or not. 7 target, right? 7 is equal to 7. So this is one valid combination we have got. So let me delete this one for now. So first valid combination what we got, 2, 2 and 3, right? So this is one valid combination. So let's start including the 3, right? So step 1 what we will do, we will start with the empty combination and the target 7. So empty combination, same thing that we did in the last step. We will start from here again for the 3, from 3, right? We'll start with the empty combination and the target 7. So we will include 3 first. This one, we will include 3. Now the new target will be, combination will be 3. First of all, this I will just give C combination, and the new target will be 7 minus 3 according to this one. Target minus candidates I greater than or equal to 0. This 7 minus 3 will be 4. 4 will be target, right? So next step, we will include one more 3, right? Now the new combination will be, what we will get, 3 and 3 will be new combination. Then target will be 4 minus 3, nothing but 1 in our case. So this will be target. So next what we'll do, we'll try to include one more 3, but here we can see 1 minus 3 less than 0. This will exceed the target. So we will skip another 3. Now if we check the next candidate, nothing but 6 here. But 1 minus 6 is less than 0. This will 6. This one you can see here in the array. We have 2, 2, 6 and 7, right? Basically. So 6 is less than 0, which will exceed the target. So combination 3 and 3 is not valid. So this one, 3 and 3, this one. Combination 3 and 3 is not valid since it doesn't sum to the original target 7. So 3 and 3 will also not, 3 and 3 is nothing but 6. So sum of this one is 6. 6 is not equal to, basically not equal to 7, right? So we will ignore 3 and 3, this one. And also we will ignore 6, this one as well. The next, this one as well. We'll ignore 3 and 3 and also 6. So let me delete this one. The only valid combination that we got till now is 2, 2 and 3. So we have ignored 3, 3, and also 6. These two things we have ignored. Next, we will include 7 directly. Why? Because 7 is equal to 7. We can see here. We will start with we'll start with the empty combination. We will include 7, basically 7. The new combination will be, so I'll just give, sorry, 1 second. Now the new combination is nothing but C. 7. And the new target will be 7 minus 7. That is 0. The combination 7 is valid because the sum, it sums to the original target 7, right? So 7, then we will check whether 7 equals 7. So 7 is equal to 7. We will add one more valid, this one. number to the array, nothing but one more combination to the array, nothing but 7. 2, 2, 3 and this and 7. These two things we got now. That is same as the output that we got here, right? So these two things. So combining all the valid combination, we got 2 to 3 as well as the 7. So this is it. Next, let's see what's the time complexity and the space complexity. Just give me a second. So the time complexity would be big O of 2 to the power of n into n. So why the time complexity is big O of 2 to the power of n into n? Because due to the exponential combination as well as the array construction. So I'll just give big O of 2 to the power of n into n. So what's the space complexity? Space complexity is same thing, 2 to the power of n into n. Why? Because we are storing the combinations and also we are making use of the recursion stack as well. So here you can clearly see we are making use of the recursion stack, right? So far. So the space complexity would be 2 to the power of n into n. So yeah, this is it. I'll just comment this one. Yeah, this is it. Thanks for watching, guys.